So I'm going to do this a little differently today. I'm not doing any slides, doing this live, or at least the morning session live. We'll see how this goes. And I'm going to kind of show you kind of more interactive is the idea. And we're going to just go with this and see how it works as far as being a little more interactive and a little more hands-on type, if you will. Rearranging my microphone, I realize that's not going to work if I'm doing this live. Okay. So we're going to talk about HTTP and hopefully just a little more deep dive in HTTP than you normally get, and then look at some examples in Delphi. And the examples I'm going to use the net HTTP components, which work with C++ Builder as well, and they work across all platforms. So while I'm going to be looking at Delphi specifically, this will work as well with C++. I'm also be running this code on Windows, but all this will work across all platforms as well, including Linux, although I'm going to be doing GUI applications, but the HTTP components are not tied to GUI applications specifically. Oh, hey, look, everybody's joining. Fantastic. Great to see you. So if you want to follow along a little bit, you actually can. If you got here to this page here, delphi.org/HTTP, which looks a little differently, I guess. If usually, you work HTTP like that, which that works. But it's delphi.org/HTTP. We'll bring you to this page here, and you can follow along. So I have a few links here. I need to link to actually this other page as well. Method definitions. I'll add that later, and then I'll also add all the code will be up here as well, and I'll have a blog post that points to this that you can get to from the homepage of delphi.org or community.embarcadero.com. So HTTP is really the main protocol we use for a lot of stuff anymore. Right? It used to be that other protocols were a lot more common. For example, POP and SMTP, POP3 and SMTP, we'd use for email. But anymore, it feels like at least, we're using a web browser for our email even. We're using Gmail or web-based Outlook. It's really becoming that the web browser is our operating system that we use the most often. Even, I find I'm using the Google Office suite, right? Their Google Docs a lot more often than I do the standard Microsoft ones. So we're really using HTTP a lot. So I'm going to just take a little bit of a dive in here, and hopefully if people do have questions about this, they can put them in the question panel, and we'll try and answer those as well as we go along. But we're just kind of trying to understand HTTP a little bit more. Now, for starters, there's different methods that you use when working with HTTP. Most often, we're using GET. So GET is what you use to get a web page or get a image. Now, HTTP is a pretty simple protocol. It's just there's some text headers that you use on top of just a TCP/IP socket. So we can actually simulate HTTP through telnet. All right. So I'm going to just show you here. What I've got is these are some simple HTTP requests that we're going to put into a telnet terminal, and this will work across all platforms as well. Although there is a curl, C-U-R-L, that you can use that is available on Linux and Mac OS, and actually a curl. They're generally available by default on those platforms, but you can download it for Windows as well. Curl's a really powerful client for dealing with web pages and stuff like that. So if you want to do some cool stuff, you can use curl. But we're actually going to go lower level, and we're going to just really look at what's going on behind the scenes. So HTTP by default operates on port 80. If it's HTTPS, that's on port 443. And the difference being is HTTPS uses SSL or TLS to encrypt the data that's being transmitted back and forth. So with HTTPS or TLS SSL, you can tell what server you're connecting to, the IP address of the server you're connecting to, but you can't tell what is being sent back and forward. So actually, let's do this here. When you're making a socket connection here, so I'm going telnet delphi.org, port 80, what I'm doing is I'm going to do a DNS resolution. So it's going to go out and find out what IP address is delphi.org, which is 216.250.120.227. I'm going to take this method here and tweak it just a hair. So I'm going to do it by IP address. I've just got another window here. I'm just going to put this in. Let's get that IP address here. Copy. And okay. So let's clear this window out, and I'm just going to go ahead and run this. So we've done telnet to this IP address, port 80. Now, in HTTP protocol, there's an extension added called host headers. Right here, you can see host. And what happened was originally HTTP, each server only had one domain name it supported. And so if you just went to the IP address, then you were able to get there, and you only had one web server on that IP address, or one domain name on that IP address, and you received it. Later on, they're like, well, we have a lot of different domain names. We have more domain names than we have servers, and so they came up with host headers so that multiple domain names could be on the same server, and then you could subdivide those. And so how that works is, you'll notice here we say host delphi.org. Now HTTP 1, this is what you would send. You would send you would send your method request. So with different method definitions we have: get, head, put, delete, post, etc. And you'd have your method and then the address of what you're looking for. And so you wouldn't tell it what server, what domain you're looking for. But then they actually added this one here, this line where you, on a new line, you put host : and the name of the server you're going to. So you notice here on this request I did my IP address, and it said, oh, we did a reverse lookup on that just for telnet purposes, and told me that this is the name of the domain there. And then here's the request we made, head, and then the name of this file, and then we tell it, oh, and we're using HTTP 1.1. Now with HTTP 1.1, you're allowed to add multiple lines after it, which in this case includes our host request, which is delphi.org, and we're also telling it to close the connection. Now the reason we're telling it to close the connection is by default it uses what's called keep alive, and what keep alive does is it keeps the socket open. So when you're making an HTTP request, you open a socket, you send the request to the remote server. The remote server uses that same socket, returns a response header, which we see here, and then the data. Now I just did a head request, and a head request is only going to get back just the headers. It's not going to get back the data itself. So it uses that same socket, sends it back down to you. Now with connection open, or the default, which is keep alive, it keeps that socket open, so the client can then say, hey, give me some more data. And the reason it does that is because most web pages are made up of a lot of different pieces. In the simplest, usually you have a web page, and then maybe you have a JavaScript file or a cascading style sheet or an image embedded in that web page, and it's going to request those same things through that same socket. Because there's a little bit of overhead in opening and closing a socket, by keeping the socket opened, it's able to reduce some of that overhead and speed up performance. Now, for simplicity right now, I'm just using connection close because I want to close this connection to speed up the process here. Because I'm not going to use the same connection to go through multiple requests. But I want you to be aware of that's how it works. Okay, so now we explain that. So this is my request here. All right, and then here is the response that came back. Now, the first thing is saying, okay, this is the protocol we're using, 1.1, And then here is the response code and the text representation of that. Now, we can go over here, status codes, and all these status codes are defined. So the most common result you get when you hit something is 200 OK. So anything in the 200 space is a success. All right, 200 OK just means boom, we're done. 201 means created. So if you do like a post or a put, and you're creating a resource on the server, then you'll get created back. So the reason I want to point this out is that originally HTTP was defined around the idea of that you could post entities to the server. So it was defined as not being just for GET requests. It was being defined as having more robust verbs, as you will. So verbs would be get, post, delete, etc. So, but most web browsers are only just using the GET requests and getting 200 OK. So REST is built around, on the idea that, hey, we've already got this robust system of HTTP that's able to do these different kinds of requests, whether it be post, put, push, pull, etc. And we'll just use that. And so if you were using a REST server and pushing data to the server, you could you would get something back like a post, right? So if you did a created, you would get a post back, for example. You could also do a delete, and you would get back, let's see, I guess probably getting accepted. All right, so there's lots of different responses you can get here. So let's look at these here. You have informational, which is 100. Anything in the 100 space is informational. The most common one you're going to get is continue, although you also get switching protocols if it's switching to a newer version of HTTP, which doesn't really happen. It's not often that you're going to make a request starting at HTTP 1 and then switch to HTTP 2. There's the 300s, which are redirections. These are ones you're not going to see in your browser. Your browser is just going to be redirected automatically. This happens a lot, and we don't even know it. Even multiple choice. So multiple choice says, hey, I've got a few different URLs you might use. Pick one. Your browser usually just picks that one behind the scenes. It takes the first one. Move permanently would be, hey, we've moved to a whole different place. So this one's important if, for example, you want Google to update where your website is. Use move permanently, and Google gets that and says, oh, I'll update my index to use a different address, and it uses this, and it goes to that different address. Temporary redirect, there it is. 307 is temporary redirect, which means, oh, for some reason I'm not available here right now, but I'm available someplace else, so go there, but don't update your indexes. All right, so those are 300s, is the redirections. 400s are errors, 404 being the one we see the most often, which means, hey, not found. So 400s are errors that are client errors, which means there's something the client can do to fix this request, okay? So if you make a 404, it's like, you asked for something that doesn't exist, you got to change your request to get someplace else. That's really common. 403, forbidden, which would be a permission issue, which says, I found what you're looking for, but I'm not going to let you access it because you haven't signed in to something you're not authorized correctly. Payment required, that's an interesting one. Right there, payment required. Reserved for future use. This is interesting that they added this for future use, but it's still hasn't been implemented because HTTP has been around for quite a while at this point. Let's see, request timeout, conflict, gone, a whole lot of different errors. And then the last type of category is 500. 500 is a server error. So 500 means, yeah, you got what you're looking for, your request appears to be valid, but I can't respond because something's happened. And so usually it's just going to get a 500 straight up, which is would be like if a CGI script fails, right? So if you've created your own Apache module or HIS module or CGI script, and that fails on the server, or the server itself is having some sort of internal issue, you'll get internal server error. Bad gateway would be if you're hitting a gateway, which is or a proxy, which is going to connect you to a different server, and that fails, then you get a bad gateway. Gateway timeout, as it says it's not able to get there, etc. So these are some of the internal server errors. So these are just some of the different responses you could get at your very top level of the response here. Okay. The next things we're getting back here is we see content type. So it's saying it's a plain text document because it's a .text file. If I was to request a HTML file, it would give me a different description here. Content type, this is the MIME type here. Content length tells me the size of the document. So this is a pretty small document. It's only 154 bytes, which is incredibly tiny in HTTP terms anymore. Most web pages, even the HTML of the web page itself, is huge. Connection closed, that's because I said, hey, close the connection, don't keep it alive. So it says, okay, we've closed it, we're not going to keep it open for you. This is the date on the server itself. This is the last modified. This is the date the file was modified on the server. So this file's been on my server for quite a while. Wow, 2010. That's interesting. Server is Apache. Usually you're going to have some version information on here as well, but not always. And then you have this Etag here. So Etag uniquely identifies this document, this resource on my server. Now, if the server has multiple, it identifies, I think, yeah, within that domain. So within the Delphi.org host, it uniquely identifies this. Now, this could be a text representation of the last modified date, for example, or a numeric representation of that. It could just be the last modified date. This could be a string that is there so that you can, if the file is modified, the Etag has to change. If you have two files that were created at the exact same time, they have to have different Etags. Okay, so if the file's modified, it has to change. You could use a hash for the Etag, but it's not recommended because of speed, although the reality is that hash algorithms are pretty fast. So it could be some servers use hash algorithms, some of them use some sort of variation of the last modified date, etc. But this is just a unique thumbprint for that. And it's used for caching purposes. Go over here to header field descriptions, and this is where we'll show you, so I was doing a search on here, let's turn that off, show you or explain what these different things are. So Etag is used for uniquely identifying it and if it's changed or not. So if the Etag will tell you if it's changed or not. I just saw a comment here from Robert, and this is actually a really good point. I meant to mention this and I forgot to. The essential distinction between 400 responses that are temporary errors, so that you get a different thing if you retry, whereas a 500 errors are permanent errors. That's a good point. If you're getting a 500 error, usually that means there's nothing you can do to fix it. 400 error means there's something you can do to fix it as the client. For example, 404 means you've maybe misspelled the URL you're looking for, and you're like, oh yeah, I meant to put this on the end of, different extension on it, and you're able to get there. 500 is like, whoa, hey, you made a good request, but I can't respond. The server's like, sorry, not a good day for me. I'm not going to be able to respond for you. Oh, I didn't even mention this. There is an error that was added. So you'll notice the 400 errors end at 417. There actually is HTTP 418. So these RFC documents are used to define. So this is RFC 2616, which is HTTP 1.1. So they make these RFC documents, request for comment documents, that are used to define different protocols. And every April Fool's they publish, or not every April Fool's, there's actually a few that didn't. It's frequent that you'll see April Fool's RFCs published. And there is this one here in 2014, the Hypertext Coffee Pot Protocol, that was published. And So let's see, April Fool's RFCs. So here's a list of some of the April Fool's RFCs. So there's actually a few years there weren't ones that weren't published. Yeah, 2016, there was no April Fool's RFC. So anyway, 418 is the error an error that was introduced for I'm a teapot. So 418 means that you've tried to brew coffee on a hypertext-enabled coffee pot, and that coffee pot is actually a teapot and not able to brew coffee. So it's mostly it's funny because I don't know, I find it hilarious, and this is my favorite HTTP error. And the interesting thing is I've actually encountered this in the wild. Somebody was trying to build a client for the AOL Instant Messenger platform way back when AOL Instant Messenger was a thing, and they were getting a 418 error, and I'm like, I have no idea what a 418 error is. And it turned out they were trying to connect to a URL, a service endpoint, if you will. This is back when they were called service endpoints, without getting a token ahead of time. And so the server was returning 418, basically saying, I don't know how you got here, you shouldn't have gotten here, but now that you did in the wrong state, I'm going to give you a 418. So probably there was a different header or a different status code they should have used, but because they weren't, AOL defined both the client and the server, they used a 418. So that was kind of funny to see that in the wild. And occasionally you'll see other references to this. Other servers could return this as a response that says, yeah, we're funny, and you should not have done what you just tried to do. So anyway, 418, there it is right there. This also adds other commands. So instead of using post or get, you can use brew. Right, so instead of using post, you say brew. You would say brew. Yeah, so right here, instead of saying head, you'd say brew. Okay, get retrieves the coffee from it. Anyway, I thought it was quite funny. All right, where was I at? That's right, I was talking about Etags. Okay, accept ranges. First of all, the response headers are mostly optional. That's one thing about HTTP it's very much a suggestion, which is interesting. The RFCs, requests for comments, actually don't define standards from a technical point of view. They say, hey, this is an idea we're putting forward, and then people implement that idea. But there frequently are very open to interpretation. Okay, so this RFC, all these things are optional. So this one here, accept ranges, is the server's way of saying, I will accept requests for ranges of this document here that you just requested. So HTTP test file, I'll accept requests for ranges of that. So you'll typically see this unless either A, the server doesn't support it, or B, if the size of the entity that's returned is unknown. Okay, so if content length is blank, because it's like, I don't know how big it's going to be. Now, you'll occasionally see this if you're downloading a file. Let's say you're downloading a file from a server that's giving you a collection of files together. So say you have like Google Images. I'm not sure if Google Images does this, Google Photos. And you're like, I want to download all my photos from this folder. It will give you, it says, okay, here you go, downloading the data, but I don't know the length of it because I don't know how big all these images are going to be by the time they're finished zipping up. So it's in the background, the server's zipping them up into a bundle, into a single file, and giving you those files all while you're downloading it. And so it doesn't know the actual size that's going to be when it's done. And so in that case, your content length will be blank, and your accept ranges will be blank. This one here, accept, control, allow origin, is what's used for cross-origin cores. I should have opened a page up for this one. This is really interesting, actually. So cores fixes an issue they had where it used to be really common that one of the ways people would okay, so imagine you have a forum, okay, and on your forum people can post, and some people can post embedding HTML in that forum, and then someone else comes by and reads this message board. So before CORS was introduced, access controls, you could go to this forum and you could post JavaScript that got embedded in that forum page, and then someone else could come by and read that, and the JavaScript would execute on there and pull in JavaScript from another site and maybe look like, oh, you need to log in to this web page. You're like, oh, I thought I logged in, and you log in again, and that password, username password, is redirected to this other server and posted there where it's retrieved so that now all of a sudden they've captured your credentials. And so what they did is they added this idea of CORS, cross-origin resource, I can't remember what it stands for, cross-origin resource sharing, there it is. And what it does is it lets the server define, hey, I don't run scripts unless they come from here. Now, this one is set up very insecurely, which I didn't realize this was set up that way until I was poking around in these header response. And this says, oh, you can run scripts from anywhere. So basically what that means is that if someone was to embed a script or request a resource from another server, my web server would tell you, hey, it's okay to run that script. I don't care where it came from. So that's very insecure. But by default, this could be restricted to only certain domains, and that would prevent you from being able to run scripts from other domains. It's just a security measure. Okay, so now we've looked at the different header parts here. So now I want to look at a little more interesting things you can do here with this, and we're going to first of all let's do a telnet with a get, and we'll actually get the document here. Okay, so again we have our request here. Here's our response header, which is exactly the same, but now we have the contents of the document, and so that's this here. That's the contents of the document. This line here is sent by telnet, just saying, hey, the socket closed, because in telnet usually you're not expecting the server just to terminate on you unexpectedly, but because I say connection closed, it's going to do that. So this document is self-describing. It says, hey, line 1 is 76 bytes long plus a carriage return line feed, which brings the links to 79 bytes. Total file size is 154, which you can see right here, 154. And there's an X at the 127th character. So that right there is the 127th character of the file. So if we wanted to just get just the first line of this file, we could do this here. So right here we say range bytes 0 to 77. So this is inclusive. It says I want everything from byte 0 to byte 77, and that's going to return the entire first row. So let's go ahead and run that here. Oops. I should have put this, let me do that. Actually, I'll put this all in my okay. Wrong one. Okay, so let's do that. So now you'll notice in our response header we get here, we get a 206 partial content. So this is saying, hey, I understood your range request, and I'm only giving you back 78 bytes. And this is bytes 0 through 77 of a total of 144 bytes. And so that's what's going on here. And if we look, we see, we just got line 1 of that file. There, okay. So now we can get a little more interesting. We can actually say, I want bytes 115 to 154. So we can pull something out of the middle of it. Let's do that here. And that we pulled out just this line here that says there's an X at the 117th or 127th character. So we pull out the last line of it. And we can do, let's see, I don't remember what this one does. 78 to 113. Oh, you know what it was, is the 78 to 113 doesn't have a carriage return at the end. And so this connection closed by foreign host went over the top of it. So that one's not very interesting. Let's get just the X. So that would be 127 to 127. So let me just modify this here. 127 to 127. And this might not work on Mac OS because it overwrites that line. Oh, there it is there. So there's the X. That's what I was trying to get. So we got just the X from the end of it there. Now this last one here is supported by the standard, or not the standard, remember it's not actually a standard, but supported by the HTTP document recommendation, is that you can actually combine multiple ranges. But they changed my web server so it doesn't work anymore. It worked at one point when I originally put the script together, but it doesn't work. And this would give you back multi-part response, and so you'd actually get two different chunks back, but it doesn't work. If I do this, it only does just the one chunk and doesn't do both of them. So I'm not sure if that just is not supported by Apache anymore, or if they changed the configuration of my web server. I'm using a shared hosting account here for this one, or what's going on. But it is no longer supported by the web server. It was just kind of a mild curiosity, really, to show that that's the way it works. So the reason the range requests are interesting is because this lets you resume large file downloads. So let's say you're downloading a really large HTTP file, or a really large file over HTTP, and the connection fails partway through. With resumed connections, you can do, you could restart that download. And so you can actually do something like this. So let's do, I'll show you what this one will look like. Here. So I did a bytes 127 through. Okay, so this says, give me everything starting at 127 all the way to the end. So if, let's say, you're downloading something and you get only halfway through it, and you're like, okay, I made it to byte 127, but I want the rest of it. You'd say, or I made it to byte 126, but I want the rest of it. You'd say 127 through. So remember, this is inclusive. So this is starting with byte 127 all the way to the end. Which we see we got here, X at the 127th character. Okay, so something else interesting you can do with this is you could actually split a download over multiple servers. This used to be a lot bigger deal than it is now. It still can make a big deal. For example, in the Get It downloader actually does this, the newer one, is when it's doing the install, it opens two connections to the server and downloads both at the same time. And what that does is it's able, because on a client side we have a much larger, faster connection frequently than the server is throttling it to. And so by opening two connections, it's able to get twice as much data transfer going at the same time. So what you do is you divide the file, the large file you want, into two pieces and download both of them at the same time. So you can download from two different servers or from the same server if the same server, if that server is throttling you. So let's take a look at what this would look like in Delphi. Now, these are some, I'm going to use these in one of my examples, this image here, but what I've done is taken this regular image here, this picture of downtown Tokyo. I did not take this picture, but I was just in Tokyo recently. But it's a cool looking picture. It's my wallpaper in Windows now. And I've converted it to different tints here. So we got blue, green, red, yellow, teal, and purple. Okay, so let's go into Delphi. And I was just looking at the time. I was going to build some of this from scratch, but I'll just show you what this does here. So this is an HTTP debugger I've made. And what this does is it lets you, just a GUI interface that wraps the, there it is. A GUI interface that wraps the new HTTP client sockets. So we got these new components here. Actually, I'll just show you on the tool palette. HTTP, HTTP client, and HTTP request. So these new sockets were added, and they are native socket wrappers that work across all platforms. So if you remember, we used to have Indy. We still have Indy. Indy is really powerful. I love Indy, but it was its own implementation of the sockets. It's still ultimately wrapped the native socket, but Indy implemented its own HTTP protocol on top of the platform's socket, whereas this one wraps the HTTP support of the platform. Okay, so that's the difference, is this one's one level up from Indy. And so what that means is, with Indy, if you're connecting to a server that compresses it, because one of the things you can do is you can say, hey, I accept an encoding of gzip, which is the most common encoding used online. And gzip means I'm going to get back a zipped compressed response. And so what it's going to do is going to compress the HTTP down in response. 90% probably of HTTP page or HTML pages and JavaScript pages and cascading style sheet pages, text documents you get back, are compressed with gzip. And actually Google has some new compression algorithms that are really cool looking that they're using now beyond gzip. But it's all compressed automatically. The browser just says, hey, give me compressed because we're saving bandwidth. It makes it faster. With Indy, if you're getting back a gzip response or an HTTPS response, so that's encrypted, then Indy you have to put down other sockets to handle the compression, to handle the encryption, and deal with those automatically. With these new sockets here, the HTTP client sockets, they use the platform's already built-in support for gzip decompression and HTTPS decryption. So that means that you don't have to worry about the compression and encryption. It's handled for you automatically. So that's really great. Handle all your certificates and everything like that. So what this is here doing is this is letting you compose your headers that you would do to make a request. So there's some additional headers in here. There's accept. This is where you say, this is the type of document I'm going to receive back. Most of the time, the server looks at what you, so .text, the URL doesn't have multiple representations, but if the URL, if this document does have multiple representations that represent it, this will define that. So this is a really big deal in REST. If in REST you're making a request that is, you could say, oh, I want it in application JSON or application XML, and it would give you back the representation, the response in that format. Okay, so it could give you back in JSON or XML. A lot of REST servers will support both, for example. This is pretty common, typical request header you'll see, accept header you'll see for a web browser. It says, I want text HTML or application XHTML plus XML or just application XML. And that's what you'll receive back. Actually, one thing that here's interesting is you'll see sometimes like this, and it says, I want, and you have this Q equals. All right, and so what this does is it says, so here, this is an example. It says, I prefer this one here, audio basic. But if I can't get audio basic, or the quality is 80% lower for audio basic, then give me any kind of audio. I don't care. And so that's what this here is used for. And so you'll see this a lot. So here, accept says, I prefer, let's see, I prefer, oh, this one's all in scrambled order. Okay, here, decipher it for me. So it says, I prefer text HTML level 1, but if I can't get it, then I'll take all these different representations here. So this just gives it the ability to say, this is my preference, but give me different types. And so you can, you'll see that a lot in the header. I didn't include that in the ones I made here, just for simplicity's sake. So this is the representation I want. This is the character set I want. So we're wanting Unicode, which is what the default is typically. We want gzip. One thing that's interesting about this is if you don't specify it, it's supposed to give it to you as plain text if you're making a plain text request. But some servers, like for example Stack Overflow, always compress it, even if you don't ask for it compressed. And their logic is, hey, we're saving bandwidth. If you have some sort of funky client that's not able to handle compression, that seems unlikely, so we're just going to give it to you compressed anyway. Refer is an interesting one. What refer does is yes, the code will be available after the webinar. I haven't uploaded it yet, but I will upload it. And you can get this debugger. I actually had some other features I wanted to implement on it and didn't get implemented on it, but it's still pretty useful, I think. Refer is where did you come from. So in HTTP is all about hypertext following links from site to site. And so refer is like, hey, I was on Google and I clicked the link and now I'm on delphi.org/this here. Okay. So some servers will actually look at the refer and say, okay, if you did not come from my server, you can't get this image. Okay, so to prevent hot linking of images, which is where you embed an image on your site from another site, they'll use look at refers. And so when you make a request for an image, it'll say, did you request it from my site? You did. Okay, I'll give you the image. If you didn't, then I'll give you a little thing back that says, hey, don't hot link my images. Again, not as common as it used to be, but you still run into it occasionally. You can also use refer to make sure that they took the right path to get to this resource if you're using authentication. User agent is defines the client they're using. So let me go ahead and run this. This is the user agent for Chrome on my Mac. Mozilla, I'm not going to get into the full history of this, but the Mozilla was, so Mosaic was the first web browser way back in the day. I think it was first web browser. It was one of the first successful web browsers. Mozilla was a web browser created by Netscape. It was the code name for Netscape Navigator, or Netscape. That was the Mosaic killer. That's where the name comes from. But then they also had this little dinosaur, Godzilla type representation of it. Anyway, that's where that name comes from. So this is saying I'm using Mozilla 5. Everything is based on Mozilla 5 now, which is interesting because it used to be there was lots of different ones, but pretty much everything does that. And so what this is doing here is this is saying I'm Mozilla 5 compatible. And this is my OS, a Macintosh, Intel, yada, yada, yada. I'm using, but then I'm also compatible with this, Apple WebKit. And I'm also Chrome, because that's what it actually was. But I'm also compatible with Safari. So each of these are saying what I'm compatible with. And so then the server can look at this, and it can actually be very specific and say, hey, I'm going to change what I'm serving up based on, oh, your Apple WebKit 537.36. Okay, so I will give you you support the feature I need, and so I will give you different content. And so actually I've gone through and grabbed all the most common user agents and put them in here for you so you can simulate this. Now what this means is some servers will say, I'm only going to serve content up to certain user agents or whatever. Or the server can say, oh, can tell what version of Windows you're running or what OS you're running, Ubuntu versus Windows versus Mac, to give you Gecko's a browser on Linux, so it's interesting that they're saying they're Gecko compatible. A lot of times this will be based on the engine that's being used inside the browser. So the server can use this information to respond. Most servers don't care. They completely ignore this. But some do under certain circumstances, so it's important to understand what's being transmitted here. A lot of times people will leave this blank when they're developing their own application, and some servers will be like, whoa, I don't know what that user agent is. I'm going to kick it out. Or they'll decide that means you are have nefarious purposes, which you may have nefarious purposes, but if they might decide that if you don't have a user agent that you're up to no good, and they will just ignore your request. Here's the method, get. So here's the common methods, some of the common methods, including options and connect. Options says, tell me what you support. So it'll come back and tell you all the other headers it supports. And connect turns it into a tunnel. Not always supported by the server. So let's go ahead and execute this. Let's do the full range here. I should have put the thing in there to clear that. Execute. So here we go. That's the document that came back. Here's the headers from the server. So HTTP 1, 200 OK, everything like you saw before, except ranges. Now, actually, I'll mention one note here is the except ranges. There's two responses that can happen here. One is bytes, which says I'll take range requests in bytes, and the other one is octal. I've never seen octal implemented, but it is supported by the HTTP RFC. So if you do get octal back, then no, you have to calculate your ranges in octals instead of in bytes, which, yeah, good luck with that. Okay, so this says I accept range requests in bytes. So we're going to say, okay, give me that range there, and there we go. There's an X at the 127th character. Okay, so I was going to add the ability here to add arbitrary headers to the request, but I didn't get that done. I might add that later. But there you go, and we'll take a look at the code really quick. It's really simple. So on the form, we have our HTTP client, but then in code, I'm making a new HTTP request each time, and I did this just to clear out the headers, so there was no funky headers laying around between requests. You don't want to set the value of a header unless you actually have something to set it to, okay? So if, I guess URL is not a good example because you always have to have a URL, but let's say we didn't care what we accepted, and so our accepted was blank. So that's where we define the characters, the encoding, right? If we left that blank, then it would, if we just set it with a blank value, then you get an error back saying, whoa, you have a blank header, which you can't do. So this just checks to make sure that we actually have a value defined before we put it in the header. So these are all the accept, character set, accept encoding, language are all defined as properties. But then things like user agent and range and referrer are not defined in the as properties, but you can define them using custom headers. Now, one note is referrer is actually spelt incorrectly in the HTTP RFC. I'm not sure what the backstory is behind that, but I thought that was quite amusing. So if you're wanting to specify the referrer, you specify it with one R. Referrer, but yeah, so that's interesting. So then I just execute my request I've created here, which is going to use the HTTP client, and I get the response, the content as a string displayed in the memo, and then I go through the headers and add them to a client or FD mem table to display them in the grid. Okay, pretty easy, pretty simple there. The other one I made here is this HTTP stream example. This is a little more complicated. And what this does is this, remember I told you about those images I had here? So what this does is it, first of all, looks at this image here and then divides the request up over these images. And it uses the bitmaps. Now, one thing about bitmaps is a bitmap is just raw data, whereas a JPEG is that it JPEGs, because they're compressed, each one of these will be different sizes, the JPEGs, plus you can't really do display part of a JPEG, whereas a bitmap you can display part of a bitmap and it'll work fine. So what this one does is we first of all go and get the original bitmap, the head for it, so we can find out the length, and then I divide that length by 12, and I'm going to split that up over multiple requests. Then for interesting sake, I actually go get the full bitmap and add that to my where's that? Oh, my mem stream. So I have a memory stream I'm putting this all into. And I put that in there. And then I'm going to go through, and I'm only going to get part of them, part of the split ones, the ones I split up over these different colors. And I'm going to request, using a range request, of the bytes, so the chunks of it there, so that it pulls up this different ranges. So it's splitting the request over multiple files, each file being different colors, so you can see it when it's done. And then I'm combining those streams together and then loading them into a bitmap on the form. So let me run that here. We've got progress bars going as well, and this also is going to show the status. So you might not see all the details. It's going to go pretty fast. I should slow this down. So that was the first request. There's all the individual requests. And when we're done, we have, this is the original image, and then these are the colored bands that are loaded from other images. And so what this means is that this is a combination of 7 different streams that are combined together here. So the original image and then 6 different colored bands. 1, 2, 3, 4, 5, 6, 7. 7 different colored bands. So 8 streams are combined together to show you to create this final image. And so these bands could have been, like I said, downloaded parallel from multiple servers at the same time in order to speed up performance. So there you go. That could be interesting. The requesting part of a file could be useful. For example, if you have like a zip file on the server that's rather large, you could use the range request to download just the header from the zip file and find out what's in the zip file. And you could, in theory, download just one file out of a zip file and decompress on the client side. So pretty powerful stuff here, showing you how to use it all in Delphi with the new HTTP components. So real quick, let's go to the questions. A few questions are coming here. What's needed on the server in order to split a file download? So in order to split a file download, all that's needed on the server is the server has to support range requests. So the server responds with accept ranges bytes, and it has to know the total length. So that first request I did where it came back and had the total length at 154, content length at 154 because it's the full, because it's a 200, and then range accept range bytes. That's all that's needed on the server. And then on the client side, you could split it. Could file upload also be split? FTP supports this. It's a completely different implementation, but yes, FTP supports resuming files on the server. I don't think it supports parallel uploads of the same file, but it does support resuming files on the server. Yeah, so Stefan shared a link, yes, about why the refer versus refer. I haven't looked at that link there, but most so the interesting thing is because HTTP is a recommendation and not a standard, that a web server could support both refer with 2 R's and refer with 1 R. So it's not, like I said, not a hard, fast standard. Okay, if there's any other questions, go ahead and put them in now. We're getting up at the top of the hour. This took a little longer than I expected it to, but I ended up explaining lots of things. It's one of those things that I started building this, I realized there's a lot of stuff. There's no way I'm going to cover everything about HTTP in here, but hopefully cover some interesting bits that are useful for you all. So I will get the code uploaded on delphi.org, and you can, I'll have it on this page here, delphi.org/HTTP, as well as in a blog post and on community, so you can download those there. Okay, well, I'm glad everybody enjoyed this. Hopefully this is useful and beyond just novelly interesting. Yeah, I don't have the sample uploaded yet, but I will. It'll either be on delphi.org/HTTP. Actually, I can put this. It will be here and then I'll also have it on delphi.org and community.embarcadero.com. Okay. Well, thanks so much for joining me. Hopefully this more just conversational session was interesting and useful for you all. And we will see you online and talk to you later. Thanks a lot. Bye.